Okay, so I'm going to just kind of review what we've talked about so far with energy and give you a chance to practice. If you don't have out your notes on energy right now, please take them out. And what we're going to do is just kind of do a couple examples together. Okay, and I'm going to ask you to kind of stop the video and make some predictions and do some calculations, okay? And we'll do 2 questions together, and then you'll have a chance to practice the other ones. Right, so let's see, the first one, we're going to have an object that is compressing a spring, okay? And this object, we're going to say, has a mass of 0.5 kilograms, and it has, the spring is compressed a distance of 0.3 meters, and the spring has a constant or stiffness of 100, let's say 1,000 newtons per meter. Okay, and so the question is that I'm going to ask you, the first question I'll ask is, how fast is this going when it gets, let's say, a distance of like 3 meters above the spring? Okay, and so in order to do that, we're going to make an LOL chart, and I want you to think about what kind of energy we have at the beginning here. Okay, think about that. What kind of energy do we have right here at the beginning? Well, we're going to have elastic potential energy because the spring is compressed. Okay, let's say that we have 5 boxes. Okay, as that spring releases, it's going to push it up into the air. Okay, and that elastic potential energy at this point will be transformed into what energy or energies? Okay, so what are you going to have right here when it gets to this point as it's flying upward? Hopefully you said, well, there's going to be some gravitational potential energy and some kinetic energy, meaning that the gravitational potential energy increased and the kinetic energy increased. So this elastic potential energy was actually transformed into potential energy and kinetic energy. And so let's just say maybe there's like 3 boxes of one and 2 boxes of the other. Okay, so now we need to put in our equations. So under the circle we put our equal sign. Okay, on this side we have gravitational potential energy, so we do mgh. We have kinetic energy, so we add to that 1/2 mv squared. And then on this side we have elastic potential energy, which is just going to be 1/2 kx squared. Okay, so to solve this, we want to solve for h. So we're going to substitute in values. For k, we're going to put 1,000 newtons per meter. For x, it's going to be 0.3 meters. On the other side, for m, it's 0.5 kilograms, and then 9.8 meters per second squared, and then our height of 3 meters. Then we'll add to it 1/2 times 0.5 kilograms times our velocity. We don't know our velocity. That's, I guess, what we want to find. So we leave it as v. Okay, so now we'll do some simplifying. So go ahead and take out your calculator, okay, and do these calculations. So first calculate how much elastic potential energy there was. So we get 45 joules of elastic potential energy. On the other side, here we have gravitational potential energy right here. Go ahead and calculate how much gravitational potential energy there is at 3 meters. So you should have got, there's about 10.2 joules of gravitational potential energy. And then finally here, this would be 1/2 times 0.5, or 0.5 times 0.5, which is 0.25 times v squared. Okay, go ahead and solve now for the velocity of the box as it gets to the 3 meter height. Okay, so to do this, you'd subtract 10.2 from both sides. Alright, and you would get that, so 45 minus 10.2 is 34.8. So you get 34.8 joules is equal to 0.25 V squared. We're going to divide by 0.25. Okay, we get 139.2 equals V squared. And then the last step would be to take the square root of both sides and find that the velocity is about 11.8 meters per second. Okay, so that's about how fast the box is going when it gets to 3 meters. Okay, the second question is, well, let's see how high the box is going to go. So what is the maximum height here this box can fly? Okay, so at this highest point, what's changed about our energy equation? Think about that and then put in your answer. Hopefully what you said is that at the highest point, all that elastic potential energy you started with has been transformed into gravitational potential energy. Okay? Which means there's no more KE left over. So when we write our equation, it's just 1/2 kx squared equals mgh. Alright? You know the mass, you know what x is, and you know what k is. I want you just to go ahead now and solve for h, and then submit your answer. Alright, you would substitute in for k 1,000 newtons per meter, for x 0.3 meters. Okay, for m it's going to be 0.5 kilograms. For g it's going to be 9.8 meters per second squared, and then h. Okay, all this here multiplies to be 45 joules. Okay, and then over here we get 4.9 times h. We'll go ahead and divide by 4.9 and get a height of 9.2 meters. Okay, so in this situation, we're compressing the spring of the box, and it's going to rise 9.2 meters above the ground. Okay, so I'm actually going to stop with that example there, and I'm going to have you go ahead and start working on the practice problems that go with this video. And for each problem, make sure you use an LOL diagram before you write your equation. Okay.